Now, hopefully, for those of you who were here, most of what we did Friday made sense. We were able to understand it, yes? Because that's the nice thing about solving radicals for the most part. It's pretty straightforward what we've been doing in some of our other chapters. And really, we're going to continue doing that today. But we're going to look at some more specialized situations, some specialized cases that occur. But the steps don't change. Yes, no. Even then out, or some phrasing like it. We'll have it come up again in a minute. Because when we look at this here, solve x equals the square root of x plus 6. X equals the square root of x plus 6. Our first step, is there one radical? Well, yes. Okay, if so, get it by itself. It's by itself, yes? X, the square root of x plus 6 is already by itself. Okay. You can rewrite it if we want. We don't necessarily need to. Because our next step, step 2, put both sides to the nth power. Well, our nth power in this case is going to be the power of 2. Because it's going to be the same as whatever the index is. Because on the right-hand side, the square root of x plus 6 squared, square root and square cancel, giving us x plus 6. And on the left-hand side, we have x squared. Squared both sides. So on the left-hand side, we have x squared. On the right-hand side, we have x plus 6. We have a power greater than 1 attached to a variable, yes? So we need to get this equal to 0. So what do we want to do? How do we want to get this equal to 0? Yeah, we can subtract x from both sides, telling us that x squared minus x is equal to 6. Then we would subtract 6, telling us x squared minus x minus 6 is equal to 0. So really, didn't specifically state it. We put both sides to the nth power, and now we're solving for the variable. Now, since we have a quadratic, x squared, we needed this equal to 0. From here, we can factor it, graph it, quadratic formula, any of those methods. I have a feeling most likely we want to graph it. Because if we want to graph it, we just grab the graphing calculator and hit y equals. And we type it in. X squared minus x minus 6. And hit graph. And we see that this does graph nicely. We do have two spots where it crosses the x-axis. One of them's positive and one of them's negative. If we go second graph, we look at the table. One of our solutions is at -2, and the other is at, I think it is 3. Yeah, you're good. It's easy to misalign these, especially at that distance. So x equals 3 and x equals -2, because we're looking for what values of x make the y value be 0. The only time we care about the x value being 0 is if its y is also 0. So here we have that x is equal to -2 and x is equal to 3. We have both of those there. Because if we factored it, it would just be that x minus 3 times x plus 2 is equal to 0. Well, anytime we have two or more things multiplied together to equal 0, one of them has to equal 0. And then we just solve from here. Now, if you solve it by graphing, you don't have to factor. Yes? So when we multiply, so our original equation, and again, the question is why do we switch the signs? So if we look at the factoring here, because x squared minus x minus 6, yes? So factoring, since the third term is negative, our signs are opposite. One's positive, one's negative. Now we look through the factors of 6, 1 and 6, 2 and 3. I picked 2 and 3. Now when we check, we want them to multiply together to give us negative x, yes? So x times 2 would be 2x. Negative 3 times x would be negative 3x, which gives us a negative x. Now the solutions are indeed positive 3 and negative 2. So since these are our factors, well, x minus 3 has to equal 0 and x plus 2. One of those has to be 0 for this equation to be 0, yes? Now x minus 3, if we solve it, add 3 to both sides, telling us x is positive 3, yes? Well, 3 minus 3 is 0. X plus 2, we minus 2 telling us x is negative 2. Well, negative 2 plus 2 is indeed 0. That's kind of why we have that sign flip. So it's one of those odd things that works out with solving. But if you found it by graphing, you don't have to factor. I was just doing factoring also so that we solve both. But you really just have to do one or the other. You don't have to do both. Questions on this here? Now, I think we might need to check these, especially with the wording it has above the starting problem, identify extraneous solutions. So I'm going to plug them back in. Negative 2 and 3. I'm going to start off with 3. And I'm going to replace each x in the equation with 3. Now on the left-hand side, well, it's just 3. That side's nice. On the right-hand side, we have 3 plus 6, which is 9. Square root of 9 is 3. 3 does indeed equal 3. Everything's good. Let's check the other one. Negative 2. So we have negative 2 is equal to the square root of negative 2 plus 6. On the left-hand side, we just have negative 2, yes? Inside the radical, negative 2 plus 6 is 4. Square root of 4 is 2. And we get that negative 2 equals 2. Is that true? No. So x equals negative 2 does not work. X equals 3 is our solution. That's our only one. And the issue, or the reason this comes up, is because once we got the radical by itself, we did what? We squared both sides, yes? And on that one side, we just have x. And when we square something, we have the positive negative case. And for our negative 2, for it to actually be equal to 4, we had to square it. We need to offset that negative. And in the original problem, there's nothing to offset that negative. So that's why we get both. It's an error just in how the problem is solved. We do get the correct answer, but it does give us additional information that has no meaning in the context of the original problem. Any questions on this here? We're going to look at another one. We want to solve x equals the square root of 20 minus x. Now, at this point, you might be wondering, well, correctly, this is going to definitely have extraneous solutions. Now, it'd be nice if we knew a foolproof method to know if we're going to get extraneous solutions or not, and I do have an answer for you. If you put both sides to an even power, when we take put both sides to the nth power, if that power is even, and there's a variable not inside a radical. Like this here, we get x by itself, we have a variable outside the radical when we're squaring. Odds are there's going to be extraneous solutions. There's going to be extraneous solutions if a variable is outside the radical. If the only variables show up inside the radicals, there's nothing that's being offset with that even power. We don't have to worry about it. But it's never bad to check it, and the calculator will check it pretty easily for us. Here, solve x equals the square root of 20 minus x. Step 1, there's only one radical, so we need to get it by itself. That's done. Step 2, puts both sides to the nth power. Well, the nth power in our case would be 2. Square root and square would cancel, leaving us with this color, 20 minus x. Our left-hand side, x squared is just, well, x squared. Questions on how we got to this point here? Any radicals left? No. So we don't have to repeat steps 1 and 2. We just need to solve for x. And since we have an x squared, we need to get this equal to 0. Yes? We can do exactly like we did on the last one. We can add x to both sides and subtract 20. I have a feeling we want to graph again. Yes? One thing we could do, subtract x squared from both sides. So that will make the left side 0 is equal to negative x squared minus x plus 20. If this doesn't graph nicely and we need to factor it, we can always multiply through by -1, adjusting those signs. It'll give us the same answer. We're using the graphing calculator. We can say negative x squared minus x plus 20. Does it give it 2 nice values? Well, yeah. And our answers are -5 and 4. Questions on how we found this here? Now, just to show y'all, so that y'all can see it, and we've seen it, if you moved everything over to the x squared side. We added x, we subtracted 20. We would get this here, x squared plus x minus 20. Which, for the most part, will give us a different graph. The one in blue is with negative x squared, the one in red is with positive x squared. And they do look different, except at -5 it is indeed 0 for both. At 4, the y value is still 0. Those don't change. All the other values do. But our solutions do not change. We just flip it. Doesn't change the solutions, which is nice. We still get -5 and 4. I have a feeling that if y'all were to take a guess, would you have already thrown -5 out? Because if we check it, -5 is equal to the square root of 20 minus -5. Now on the left-hand side, it's just going to be -5. There's nothing else with it. On the right-hand side, if we were checking this, and I do it, and there is going to be a part of the test that does ask you to check it, all you got to do is type it into the calculator. Let it do the heavy lifting for you. Set it up for placing x with its value. 20 minus -5 is 5. Well, here we're saying -5 is equal to 5. Well, that doesn't work, so x equals -5 is out. We can check the other one, 4. 4 is equal to the square root of 20 minus 4. Lo and behold, the left side is 4. Again, you can grab the calculator. Second square root 20 minus 4 is 4. So our one solution for this here is x is equal to 4. Questions on this here? Is this exponentially harder than what we did Friday? Not really. Questions on this one here are problems like these first two that we did. We feel pretty comfortable with these here? All right. I want to look at this one here. So we're going to skip that one and go to this one here. Now, is the radical by itself? No. For this one here, we have 13 plus the square root of 5. N equals 3. Well, I skipped a step myself. Is there one radical? Yeah. get it by itself. So to get it by itself, we need 2 minus 13 from both sides. So we have the square root of 5n equals negative 10. Yes? That's kind of nice because, again, we said if there's a variable outside the radical, but when we take the nth root, the even root of both sides, we won't have extraneous solution. So one less thing to worry about. But given the theme of what we've had so far today, we're still going to check it just to make sure. Put both sides to the nth power. Well, our nth power in this case is second power. Well, our square root of 5n squared, square root and square would cancel, telling us 5n is equal to 100. No radicals left, so we can move on to step 4, solving for the variable. And we're going to divide by 5, telling us n is equal to 20. Yes? Questions on this so far? Well, negative 10 squared, negative 10 times negative, negative times a negative is a positive, yes? Did you put parentheses around it? You need to. Because the calculator, the question is about negative 10 being squared being positive 100 instead of negative. If you don't put parentheses around the negative 10 in the calculator when you square it, this is what the calculator sees. Negative 1 times 10 squared, not negative 10 squared. It's going to square the 10 and not the negative because we need the negative being multiplied by itself. And again, that is a good question. And if you're not sure if you need to put parentheses around it or not, put them. When in doubt, put parentheses because it's not going to hurt. Because even if it was positive 10 squared, you put the parentheses, you'll get the right answer. It's better to have them and not need them than need them and not have them. Because most of the time, that's where the big issue comes in. Now, again, I said we'll just check this to make sure. 13 plus the square root of 5 times 20 equals 3. This time the right-hand side is just 3. And we can type the other side into the calculator. Type it all in, we get 3. Yes? Well, that's way off. Because that is indeed not true. Now, that means that n is not 20. Okay. All right. I'm backing up to this step here because we said that the square root of 5n equals negative 10, yes? And whenever we take a square root, we're looking for a number times itself, yes? What number times itself gives us the number inside the radical? Is there any way this could be negative? No, because the square root, the numbers that come out of a square root have to be positive. So is this even a possibility? No, that's the reason it doesn't work, because we're saying whatever 13 is, we need the square root of 5n to subtract from it. Anything that comes out of the square root of 5n is always going to be positive. There is no way this works from the beginning. So even if we miss the fact that the square root of 5n cannot ever be negative 10, we go through our steps and check. This is no solution. And I have a feeling I know your next question is, why do we say this one's no solution and the ones we did at the start, no real nth roots? Is this here we're solving. There we're just trying to find the real roots. So that's the main difference between the two. So here, there's no solution. because the one solution we did have does not work in the original problem. We throw it out and we are done. 3m plus 10 square root of 3m plus 10 equals 1. We do indeed have one radical. So we need to get it by itself. And the first thing we can do is subtract 10 from both sides, telling us that the square root of 3m is equal to negative 9. Okay, what's next? Well, there's kind of an issue to begin with, but is there any way that this square root can be a negative? No. And I mean, if we notice this here, we can say that this is no solution, no real solution, no solution, just no solution. It just does not work. Because if I plug this in, because our original problem, clear both of these out, second square root, we'll say 3x plus 10. And this, so there's x equals 1. All right, I graph both of them. Error, error, error. So the first number for our blue one is the graph itself, 3 square root of 3m plus 10. Well, the first number we get for y is, well, 10, yes? And the y values only get bigger. They don't get anywhere close to 1. They're actually just continue to increase. There is no solution. It doesn't come back down and get 1. It won't have a solution. Window, let's go. Negative 1, 2, 20 by 2s. They don't get anywhere near each other. There is no solution. Because if we work this out and finish this out, we would square both sides, telling us 3m is equal to 81. Divide by 3, telling us m is 27. 3 times 27 plus 10 is equal to 1. That would still be 1. This would be 19, and 19 does not equal 1. Because we really wanted it to be negative 9 plus 10 to give our 1. Questions on this here? What do we think of this so far? Not too bad. Terrible. All right. This is not everything, but we're not going to finish today, which is fine. Number 13, this is the last one we'll do today. P plus 1 equals the square root of 7p plus 15. Is there one radical? Oh, yeah. And it's by itself. So, is there one radical? If so, get it by itself. We did that. So step 2, put both sides to the nth power. So we won't subtract the 1 yet. We're just going to go on and put both sides to the second power. Now on the right-hand side, it's nice because the square root and square cancel, giving us 7p plus 15. Yes? On the left-hand side, well, up to this point, it's just been a variable. It's been a number. It's been one term, and we could just square it and be done. Yes? P plus 1 squared is not going to be p squared plus 1. It'd be very nice if it was. But really what we have is p plus 1 times p plus 1. We're multiplying it by itself. Now on the plus side, p squared and 1 will be a part of the simplified form on the left, but it's not going to be everything. Because our first thing when we distribute p times p is p squared. P times 1 is plus p. 1 times p is plus p. And lastly, 1 times 1 is plus 1. So yes, as we see, we do have p squared and we do have 1, but we are missing the middle term. We still have a middle term of p plus p. And p plus p is 2p. So when we squared the left-hand side, p plus 1, we ended up getting p squared plus 2p plus 1. We ended up having that entire quadratic. Questions on how we got to this here? Now on the test, I'm going to be nice because there is a problem like this that does show up. And I do give you in the instructions that if it was p plus 1, note p plus 1 squared is equal to p squared plus 2p plus 1. Like I give you that from the start. So just to make it easier, simpler, so you don't have to do that extra step and get done a little bit easier, quicker, I do give you that. But questions on how we got through step 2. Step 3, are there any radicals left? Well, no. Solve for the variable. Since we have a squared term, we need to get this equal to 0. I would subtract 7p. Because we could subtract p squared than 2p and 1, but that's moving 3 things, or we can subtract 7p and 15 and get to the same spot. We'd have p squared, 2p minus 7p is negative 5p, plus 1 is equal to 15. And we would indeed subtract 15 from both sides. Telling us that we have p squared minus 5p minus 14 is equal to 0. Again, at this point here, we can graph it or factor it. X squared minus 5x minus 14. We do have 2 solutions. Second graph. So one of them is 7. Negative 2. 7 and negative 2. If you already guessed, which one do you think is probably not going to work? Negative 2. Negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. Our negative 2 plus 1 would be negative 1. Again, if we plug this into the calculator, we would get 1. Well, negative 1 does not equal 1. So that's out. Our other one was 7. Our 7 plus 1 is 8. 7 times 7 is 49 plus 15, 64. Square root of 64 is 8. So our only solution for this here is p is equal to 7. And that's it. Now we will finish this note sheet tomorrow, which does mean everything on that board is back a day, but that is perfectly fine. It will probably be the last week. This will be our final.